Okay, also in class, last time we talked about what a unit vector is. A unit vector is a vector that has length 1, and I showed you how to take any vector at all and come up with a vector that's a unit vector that points in the same direction as the given vector. Unit vectors are going to be important, and there's a couple special unit vectors. They're called the I, J, and K vectors. So I'm going to tell you the story in R2 or V2, two component vectors first, and then we'll talk about three component vectors after that. So V2 stands for all two component vectors, or all vectors you can draw in the XY plane, two-dimensional space. So what do the I and J vectors look like? Let me first draw an X and Y axis here. So I is just the unit vector that points in the same direction as the x-axis. So I looks like this. You know, normally when we draw vectors, we start them at the origin. So imagine I'm starting this at the origin. And it points in the same direction as the x-axis, so that's vector I. But it has length 1. Okay, when you write a vector down, I'm going to try to figure out what I is in component form. It's two component vectors, so we have to figure out what these two numbers are. Well, I mentioned that, well, if you're trying to figure out what the components are, you start at where the start of the vector is, so it starts at the origin. Then we move how much in the x direction. We're moving 1 in the x direction because it has length 1. That means this is a 1. And then we don't move at all in the y direction to get the arrow, the head of the vector. So that means this is a 0. So if you forgot, let me just say that to get the components, it's like, well, you start at the tail of the vector, and then move in the x direction, and then move in the y direction, and until you get to the head of the arrow, and then you put how much you moved in the x here, and how much you moved in the y here. So one more time, we start at the tail here, we moved just 1 in the x, and then we already got to the head, so we moved 1 in the direction of x, and 0 in the direction of y. So that's the I vector. Just remember 1, 0. Okay, and then the j vector, well, it's going to be a vector of length 1 that's pointing in the same direction as the y-axis. So that's vector j. Sorry, my j looks kind of funny there. Okay, so what are the components of the j vector? Well, again, it's a two-dimensional vector, so I'm going to put two components there. And again, the way you figure out the components is you start at the tail of the vector. You start here. And then you need to move in the x direction, and then in the y direction, and then get to the head of the vector. And you can get to the head of the vector by just moving up 1 in the y direction. You don't have to move in the x direction at all. So we didn't move any in the x direction at all, so you put a 0 there, and in the y direction you moved up 1. Okay, so that's the j vector. So one more time, the I vector is a unit vector, so it has length 1, and it points in the direction of the x-axis, and you can see the components are 1, just put a 1 for the x and 0 for y. And the j vector, again, it's a unit vector, has length 1, points in the direction of the y-axis, so in this case points upward. And if I want to write that vector in component form, it's the vector 0, 1. You just put a 1 where the y is, and a 0 for the x component. And the thing is that every vector in two-dimensional space, every two-component vector can be written in terms of I and j. So let's go ahead and do that real quick. So this example says, write this two-component vector as a linear combination of the vectors I and j. So I wrote linear combination. It means, what linear combination means is write this vector 5, -7 as a number times I plus a number times j. And there's a real fast way to do it, but I'll show you the short way, the longer way first, so you see where things are coming from, and then we can do the faster way. So I wouldn't expect you to do it this way, but this is just so it makes sense what I'm talking about here. So 5, -7, you can write it as 5, 0 plus 0, -7. In other words, I kind of just separated out the first. So I wrote it as a sum of two vectors. You guys agree, of course, that 5, 0 plus 0, -7 is 5, -7. Because you add the first components, you get 5. Add the second components, you get -7. I wrote it in such a way where there's a 0 in one of the components. So the first vector here has a 0 in the y component. This one has a 0 in the x component. And then you can kind of factor out the numbers. In other words, the first vector is the same as 5 times the vector 1, 0. Once you look at it for a second, you're like, oh, obviously, because remember scalar multiplication, what would be 5 times 1, 0? You'd have to multiply the 1 and the 0 each by 5, so you'd get 5, 0. So you can kind of write it like that, and then this is plus, and then the other one you can kind of factor the -7 out. So -7 and then 0, 1, and you can see how that's going to work, because again, if you did scalar multiplication here, you do -7 times 0, which would give you the 0, then -7 times 1 would give you the -7. And now, a couple things. First of all, this plus and minus business, we're just going to go ahead and write minus for that. And then what vector is this? That's the I vector. What vector is this? This is the j vector. So you just get 5i minus, I'm just going to write minus 7j. Okay, so you take this vector, and how do you write in terms of I and j? 5i minus 7j. And you see, without doing this work, I wanted you to see it once, but without doing this work, you can go straight from here to here. You just see how it's going to work. It's 5 in front of the I, -7 in front of the j. So that's how that works. And what's going to happen is we've seen vectors in component form. This is just another way. It's almost annoying in a sense that we even have another way. But there are some reasons for it, as you'll see in the future. But it's just another way to write the vectors and write in terms of I and j, especially since I and j are pretty easy to deal with. Okay, so it's almost like a component form, but you're not seeing the angle brackets. You're seeing additions and subtractions. Here we see a subtraction, and you see I and j there. Okay, I have this quick example here. So I'm giving you the vectors in, written in terms of the I and j vectors. Looks like we have a small typo here. I should have put this I and j in bold. Let me just put arrows here. But anyway, I have vector v and vector w, and I'm asking you to find these other things. Please understand, this vector is the same exact vector as the vector 3, -7. Okay, 3i means 3 for the x component, -7j means -7 for the y component. But instead of writing it this way, because we've already talked about how to do things that way, we're going to write in this ij component business. Same thing here. This vector is the same as the vector, well, what would the x component be? What's the number in front of the I? -1, so that would be the x component. Y component would be 2. So this vector here is the same as this. But instead of seeing these angle brackets or whatever, we just have some additions here. Makes some things a little bit easier. Okay. Oh, I erased the arrows. Well, anyway, so now that we have these vectors written down in a different way, I'm just asking you to do some addition, subtraction, scalar multiplication, that kind of thing. Here to find 2v, okay, we're doing 2 times the vector 3i minus 7j. And now the thing is, we know how to do it in component form. You just multiply through by the 2. If you write it in this form, it's kind of like just doing algebra. You just use distributive property, you multiply the 2 through. And so, not much to say here. You're going to get 6i minus 14j if you just distribute the 2. If you wanted to write it with angle brackets, I'm not going to. It would be 6, -14, but we'll write it this way. It's the exact same thing. Okay, if you're going to add 2 vectors in this form, again, same kind of thing. I'm just going to write them down separately. So 3i minus 7j, that's v. And then plus w, -i, plus 2j. All you're really going to do is combine like terms. You're going to combine the i's and combine the j's. So in that sense, the rule for by adding each component separately, it's kind of like just combining like terms. So we combine the i's together. We have a 3i minus I, that's a 2i. Okay, when you combine this term and this term together. And then when you combine a minus 7j and a plus 2j, you get a plus 5j. And once again, if you were going to write this in component form, which I'm not going to, it'd be 2, 5 with the angle brackets. Okay, and then to find the magnitude of w, that's what this means when you have an absolute value around it. You know how that works. You square each component and add them. But if it's written in this form, what are the components? Well, what's the x component? It's the number in front of the I, so -1. So you're going to square the x component, -1 squared. plus, you're going to square the y component, square the 2 squared. Number in front of the j is the y component. Then you take the square root of all that. Okay, so inside the root we have 5, so the answer to that is square root of 5. Okay, so the stuff I'm boxing in blue are the answers to these 3 parts. Okay, now let's look at vectors that are in 3 dimensions, the vectors that have 3 components, vectors that live in R3 or V3, I guess. V3 is all 3 component vectors. Well, we're going to have a third one, a J vector, but a K vector, but they're all, what we've talked about before. I is going to be a unit vector in the direction of the x-axis. J is going to be a unit vector in the direction of the y-axis. K is going to be a unit vector in the direction of the z-axis. Let me go ahead and draw an x, y, and z axis here. Okay, so there's x, there's y, there's z. So unit vector in the direction of the x-axis is going to be called I. And again, what do I know? It points in the same direction as the x-axis and has length 1. Let's see if we can write down the components of I over here. So I, it's going to have 3 components. Remember the way you find the components. You need to travel from the tail to the head of the vector by moving first along the x, then along the y, then along the z, and write down how much you moved along the x, how much you moved along the y, how much you moved along the z, and then you got your components. But if you want to go from the tail of this vector, so right here, to the head of the vector, you only need to move 1 in the direction of x, and you've gotten there already. So you don't move at all in the direction of y or in the direction of z. So those are the components of the I vector. You just put a 1 where the x is and zeros everywhere else. Okay, the J vector. Drawn in green here. So remember, it's gonna, you don't always have to draw a vector starting at the origin, but most of the time I will. And it's gonna go in the direction of the y-axis, and it's gonna have what length? It's gonna have length 1. It's a unit vector. So that's the J vector right there. Okay. Okay, so let's go ahead and write the components for J. Again, the way you get the components is you say, well, how can I go from the tail of this arrow that I've drawn, the tail of the vector, to the head of the vector by moving first only along the x, then only along the y, then only along the z. And then however much you moved, put them in. But you see here, to go from the tail to the head, you only have to move 1 in the y direction, and that's it. So that means you'd put a 1 here, and so these are going to be zeros. Okay, and then K. Choose a different color for K. So K is going to point in the z direction. Okay, and I'm sure you can guess what the components are going to be. 0, 0, 1. And as I said before, for 2-dimensional vectors, for 3-dimensional vectors, every vector can be written in terms of the I, J, and K vectors. So instead of having angle brackets and a bunch of numbers with commas, you just have a bunch of I, J's, and K things being added. So this example says to write the vector -3, 2, 8 as a linear combination of the I, J, and K vectors. One more time, I'm just going to show you the long way, but you don't need to do the long way. But you could take this vector -3, 2, 8, separate it into things that have zeros in it. So it'd be -3 and 0, 0, plus, so that one just has an x number. This one will just have a y number. And the last one will just have a z number. And then you kind of factor the numbers out. So the -3 comes out, and this is 1, 0, 0. And then factor this number out, 2, 0, 1, 0. And then plus 8, 0, 0, 1. Now this is just -3 times the vector I, plus 2 times the vector j, plus 8 times the vector k. And again, you don't have to show all that work, but it's nice to know it. You just need to be able to go straight from here to here. You know, the components are -3, 2, and 8. And then those are just the numbers that go in front of the I, j, and k vectors. So -3 goes in front of I, 2 goes in front of j, 8 goes in front of k. You can just go straight from there to there. Okay. So let's do another example where we're taking vectors written as linear combinations of I, j, and k vectors and add them, subtract them, that kind of thing. Once again, I have a typo here, so let me just go ahead and put arrows on these things. Okay, part A says to find -w. -w just means change the sign of all the components. That's pretty easy. But also, it's just like you're distributing a negative if you want to think of it that way. It's like negative, and here's w for I plus j plus 3k. But anyway, you just change the signs of all the components. So we're going to get -4i minus j. It's like the y component is -1 now. And then minus 3k. You can just write it like that. So like the z component would be -3. Okay, so that's the answer to that one. The second one says to subtract the vectors. So I'm just going to go ahead and write what v is. So v is 6i plus 2j minus 9k. You can do that minus 4i plus j plus 3k. And you're just going to subtract. The way you normally know how to subtract. You distribute this minus sign through, and then you add, or you can just subtract corresponding numbers. It's like you're going to do 6i minus 4i. So it's going to give you 2i. And then it's like you're going to do 2j minus j. It's going to give you a plus j. Think of it as just 2 minus 1 right there. So we have a 1 in front of the j. And then you're going to do minus 9k and then minus 3k. That's minus 12k. Yeah, that's the way that one goes. In component form, that would just be 2, 1, -12. Okay, a couple more little examples on this one. Once again, I lost my arrows. So part C is asking you to find a linear combination. Means, again, linear combination means multiply a vector by a number, multiply another vector by another number, and then add them. So we're going to do -2 times the vector v. And again, this times is scalar multiplication. And then plus 3 times the other vector, 4i plus j plus 3k. And remember, you got to do the scalar multiplication first. So it's kind of like you distribute the -2 through to this. So you're going to get -12i minus 4j plus 18k. And then you distribute the -3 to this part here. So you're going to get plus 12i plus 3j plus 9k. And the last thing you do is you're going to combine like terms, which is what it really means is we're adding these two vectors now. Okay, so we did the scalar multiplications, and now we're adding. When you add the -12i and the plus 12i, you know, those cancel out. You get 0i. You can write 0i if you want, or you could just not write it at all. But if you see it's missing, just remember that means that that component is 0. So those cancel, so I'm not going to write that one. Then when you add these, -4j plus 3j, you get -j. So you have -j. And again, that -j just means there's a -1 in front of the j. And then we're doing 18k plus 9k, that's plus 27k. And again, the fact that the I is gone means there's no x component to this vector here. All right, so there's the answer to that. And then part D is asking you to find the magnitude, there's absolute value around it, the magnitude of the vector we just found. So that's pretty easy. You're supposed to square each component, then add them. Remember, the x component is 0. Let me go ahead and just write it anyway. So we have 0 squared for the number in front of the I, since there's no I. Then the number in front of the j is -1, so you do -1 squared. And then you square the z component. and then square root it all. Okay, 27 times 27 is 729. And then, so that's 729 right there. That's 1, so we have 730. So this is square root of 730. You may be able to simplify that, but I'm not going to go any further than that. So let's leave it like that. All right, that's how that goes.